So, one of the questions that may arise after working with the previous relational operators is what will happen if we will try to use some mathematical operations on structs. So we know that if we create some variable, some standard variable int num equals to 5, we can write down num++, and that's it. It will simply increment the value of num by 1, and we can also write down num plus equals to 3. It will increment the value of num by 3. Okay, so we can do that for integers, floats, and so on. But the question is, what will happen? Let's comment it out simpler. But the question is, what will happen if we will use it on structs? Okay, if we use some operations like we've specified previously, like num++, if we use it on point, which is a variable of a point type. So we can write down point plus plus, point 1, which is a variable of a point structure. We can write down point 1 plus plus. But now at this point, it should be crystal clear to you that this thing is not supposed to work. And the reason is very simple, because we write down plus plus, but what do we mean? Do we actually want to take each of these fields and increment it by 1? Or maybe we want to take just the x field and to increment it by 1. And what will happen if we have a structure called employee and the first field is basically the name of the employee? Then what will it mean like employee plus plus? What will it mean? What field should we increment? How we should increment basically a field that is, or basically that is considered to be of a type like a string. Okay, so that's very important to explicitly specify what we want to do. We cannot write down point p1, point 1 equals to point 2 plus 3, because what is the result of this evaluation of this terminology? Okay, so for that, there is also some option that you should at least know for this point. That's just the basic option that we can use, and it's called to create functions kind of associated with these operations. I know it's not the most elegant way, but it works. For now, it works just fine for you. So for example, you want to make an addition between 2 points. You want to say let's say point 3 equals to point 1 plus point 2. So the way you can do it is simply by using the addition function that you created. And this addition function will receive point p1 and point p2. Both of them you want to add together to create the point result. And then you simply go over field by field, or basically by the fields that you are interested in. Maybe other fields, simply copy them, okay, if they are not part of this addition. I'm just using basic addition. And finally, once you create this point result, you return it. Okay, so that's one way to solve it. Another option, basically another function, will be to use the increment, okay, associated. This was associated with the operation of, let's say, addition, right? Instead of addition, we can use the addition function. Instead of this operator, we can use addition function between 2 points to get the added result. Okay, and we can also use it for kind of simulating the increment operator. So we will send the actual address of a certain point, and we will be able to access its fields and to add them by 1, to increment them by 1, both x and y. And if this structure had additional fields, then we would have to decide what fields should be incremented and what not. That's why this thing does not work. But if we will call these functions from here, like increment here, we can use it, increment, and send what? Send the address of point p1, then this should do the work. We will get this p is a pointer to point, it will point to this point 1, and then we will simply increment the values by 1 of this actual point 1. So after this line, what we will have is basically point 1 with the values of 2 and 3. Okay? And if we wanted to create some new value, point 3, okay, let's say something like that, point 3, and let's say it should be equal to 0.1 plus 0.2, okay, instead of writing it this way, we could use addition of points and then specify 0.1 and 0.2. And that should be good, okay? So I hope that's clear. Let's also just copy it and save it so that we will have this code right here. Come on, come on, come on. That's what we had. And that's what we propose. Awesome. So, yeah. So this is it, guys. Thank you so much for watching. Let's move on with the material now that you are feeling hopefully more confident and more believing in yourself and your skills as programmer. Good luck.